Since this is the topology that you did summarization, check whether some summarization commands are still there. If it is there, remove it. And then check whether all the routes are available in all the routers. Please start.
I seem to have lost access. Don't have the access anymore.
No, it shows Krishnanand is controlling my screen. Please try again.
No.
Wait. R3. Okay, now you try again.
No, I can't hit it.
No, you're doing it.
Yeah.
Most.
Okay.
Check whether in R3, check whether the summarization is still there. Show run section.
Okay.
No. Good. It's not there.
Yeah, range is not.
It's not there. Okay, likewise on R6, check whether the summary address command ASBR summarization. All right. Okay, now hold on. Router OSPF 1. I don't want this metric type 1. I'll simply say redistribute RIP subnets. Oh my god, no. This is not the one which I want. I don't want this, and I want. I'm simply saying redistribute RIP, include all the subnets. Okay, so RIP is running in this side, on the ISP side. ISP2, ISP1 is down, we are not focusing on that. Now let's check whether R1 knows the route. R1 has learned 56 and also 7.8.8.8. These are all external. These are all type 5. Where do we see type 5? Type this command show IP OSPF database. Yes, take control please. Show IP OSPF database. Spacebar. See? Type 5. These are all coming from other routing source.
Okay, type 5.
See,
so type 5 is the is coming from the ASBR.
ASBR. So who is giving you this 6.6.6.6, which is ASBR itself? Yeah.
So that is type 5, 4, right?
No. From where this advertisement
of...
started? From where this advertisement started? From where it is originated?
Okay.
Tell me.
Okay. From R6.
That's why you have 6. And type 4 is above that, you see. Type 4.
6.
Can you select type 4? Can you select and show me? Highlight and show me. Type 4.
Summary. This summary.
Yeah, that's all. That is the one.
This is the one. Okay.
See, it says the link ID is 6.6.6.6.
Got it. So, what is 3333?
3333 is your ABR. Your ABR will tell you.
Okay, this is my ABR, and 666 is this one.
666 is the router area of ASBR. Yeah?
6 is the okay, yeah, correct. This is the ASBR route. Correct. Understood.
And then where is type 3? Can you highlight and show me type 3?
So type 3 is summary, let's say.
Yeah, that's the one.
I think, yeah, this is the one.
So whatever you see below that is what you learn from other areas.
Correct.
These networks 4.4.4.4, 5.5.5.5.6.6.6, 10.34, 10.84, 10.76, all these are other area routes. Area 0, area 2 and so on.
These both are type 1 and type 2.
Correct.
Router LSA and net LSA, which is
Your
originated
own.
intra area.
Yeah.
Yeah.
From the local.
Okay. So all these are so basically the information that's listed out here is in the sequence of type 1, type 2, type
Correct.
3, like that.
Correct.
Okay.
Correct. Now, try pinging from here to that external network. 7.7.7.7. Ping 7.7.7.7.
I guess the reverse routing is required.
Okay, check it. Go to the last router, external router, EIGRP router, sorry, RIP router. Go to the, not here, here the routes are there. Go to the cloud, ISP2. R6 will have it. Show IP route. Check it on R6. Show IP route.
R6 and
Oh, why are you checking this? Check whether
R3.
our
So R3.
ISP2 knows about 11111.
Correct. Okay.
It is there down already.
SP2.
Show IP route. No routes. Which means on R6 we have not redistributed the OSPF route into RIP. So go to RIP and redistribute OSPF. From RIP you have given to OSPF, but from OSPF we have not given to RIP. Yeah.
Should be one, right?
Yeah. No. This is not enough.
Just want to show IP protocol summary. So it's OSPF 1. Okay. Sorry, I was in a bit of haste. So redistribute OSPF 1. Why is it not sufficient?
Go and check, no? You have redistributed, right? Go and show me the route on our ISP2. Simply type show IP route. Because, this RIP is a distance vector protocol. OSPF is a link state protocol. Now when you say redistribute OSPF, you understood. When you say redistribute OSPF, OSPF will advertise only what? Cost. RIP don't understand it. So you need to say for all the OSPF routes some hop count. How much hop count you want to give?
Just give 5 and see.
Okay, now it will go. Go to... Yes, you got the route.
Okay.
Let's go and try pinging from R1 again.
Sorry.
Okay, I want you to shut down the link between R1 and R3.
R1 and
R3.
So R1 and R3.
I want everything to go via R2. Shut down G2/0. Okay, now you ping the external route. Very nice. Fine. Check the size of the routing table. Right? This is 8,242. Right,
Yeah.
before we go into this, let me take control. Now remember, I should teach this. What is E1? What is E2? O means OSPF route, route from the same area. OIA means OSPF route, but from other area. So these are type 3 given routes. These are type 1 and type 1 and 2. This is type 3. Now E1 and E2 both are type 5. Then what is the difference? This is default. If you see on our one routing table, show IP route OSPF. If you see, it is 2 default. It's 2 default. Now, in the default, current metric that you see is 20. How this 20? It's a default metric. When you redistribute it, you have not mentioned any metric, you see. Show run section OSPF. When you redistribute it, this is coming from RIP.
Yeah, the one on the first one, right? Second line.
You see, we have not mentioned any metric for those RIP routes, those external routes. So OSPF by default will give 20 as the metric. But where it is given, the metric 20 is given on R6. The metric 20 is given on R6 for the RIP routes. After R6 it comes to R7. Metric did not get incremented. See, there is some bandwidth involved, cost involved, nothing added. Again it came to R5, nothing added, nothing added. No metric, no extra metric added. We don't have this line. You know, the seed metric we call it as the metric that got injected when you redistributed. It remains the same. You see, I'll go to R6 and give some other seed metric.
What is means how? So just trying to differentiate. How would we differentiate between metric and cost?
Okay, we'll go there. Right? Let's finish this. You see, the metric you saw is 20 because you did not mention any metric. Now I'm going to mention the metric 10. So what is the seed metric I'm giving? 10. Where I'm giving 6. Is there a cost involved between R6 and R1? Is it zero cost or some cost is involved?
There will be some cost.
There will be some cost. But unfortunately, we don't see any cost. The same 10 which I gave appears here. If I don't give anything, it gives 20 in R1. See, it gives 20 if you don't give any metric. So the default seed metric is 20. And the redistribution is done on router 6. In router 7 also the cost is going to be 20 only. Show IP route OSPF. Even here it is the same 20. R1 also same 20. This is what we call it as type 2. Type 2 means external type 2 means path cost is not added. Now I will.
Oh, I see. So the
Yes.
so in case let's assume that there are two routes being added. Means, like for example, you have shut down one of the links. So between
Only in that scenario. Only when we have more than one exit to reach the external network, we will try to calculate the best exit to reach the external. But in our case, it's not needed. Even enterprises, most of the enterprises, they don't use the other type called type 1. That's why by default it is type 2. Type 2 means don't calculate the path cost, it's waste. Why it is waste? You're going to simply have only one exit, like R6 to R7, sorry, like R6 to ISP2. You will have only one exit most of the time. So there is no point of calculating the cost involved to reach the ASBR. To avoid unnecessary wastage of process in calculating the metric, the default is E2. E2 means path cost not added. Now you are asking a question, what's the difference between cost and a metric? Metric of OSPF is cost. Metric of OSPF is cost.
Yeah, because you mentioned like that was a kind of a tricky statement or a tricky question that will there be a metric associated or not? So that's why I thought of asking.
Will there be a cost associated or not? Same, both questions, same.
Okay, so let's assume that ISP2 and ISP1 are advertising the same route with the same prefix /32. Then
in such scenario, you want to calculate the shortest ISP, the ISP whose cost is lower to be the best exit, for which you need to do this while you redistribute. See, the default is E2, but while you redistribute, kindly focus, this is metric type. I'm not giving metric like before. I'm saying metric type, meaning to the seed metric you keep adding the path cost. That is the meaning of 1. 1 means what? To that seed metric 20 you need to keep adding the path cost. So if you go to R7 now, you will see 21. Previously it was 20 in R7, but now it is 21. Why? Cost on this link, key link is 1. On R5 it will be 22. R3 it will be 23.
Oh, so 24, now it has become E1.
25.
Instead of E2.
26. Yes. On R1 it is going to be 26. Let's go and check. R1, previously it was E2 and 20, but now it's E1, and every link is 1 cost, so it is 26 now.
Oh, so the value of 1 is every it's kind of like every router it's going to cross add a metric of 1.
It's not that.
So that's a kind of variable value. Every time whatever value you add over mention over there will be the added to the path cost.
Correct.
Okay.
Now, how the metric in OSPF is calculated? When we say metric of OSPF is cost is calculated based on bandwidth, with the reference bandwidth 100. 100 on top, and the actual bandwidth on the link, 1 gig link, is 1000. It will come in fraction, but it will be rounded to 1. Now I have 1 gig link, the cost is 1. I got fast Ethernet, for that also cost is 1. Why? 100 is the reference bandwidth divided by the actual bandwidth is 100 meg. This is how many meg? 1000 meg. So now also you get what? Same answer, 1. In OSPF, by default, it is the 100 on the numerator. In the beginning days, when no one were predicting that one day we will have 1 gig, no one was thinking that, no one could imagine that we will have 1 gig, 10 gig, 100 gig links. No one was really imagining. So they thought that reaching 100 meg will be like a blue moon thing for them. On those days they thought, let's keep the upper limit as 100 meg, and we were having 56 kbps wire, and we were having maybe 1 meg wire. So if you use 100 meg on the top, you can easily get a metric value. But because of the advancement now, this formula is no more valid. But what to do? That's the default formula that is running right now. That's why the cost is 1 even in the gig link. If you will have gig link and fast Ethernet mixed in your environment, then you should go and change the numerator to be 1000, so that for gig link it will give cost as 1, for 100 meg it will give 10 as the cost, 10 cost, 1 cost. So this router will decide to pick this path and keep this as a backup. But when you don't change the numerator, OSPF will consider this both a path as equal per cost path. It will share the load among both. Now how do we change this numerator? Let me show you. But if you change on one side, if you change it on this side, you must change on this side also. Why? The hello packet that goes will carry the algorithm value. It will conflict. So you should change on both sides. That is recommended. So let me go to R1.
An interface level command.
Yeah. Right now you see, before changing, every link is 1. That's why you have 26. Now I am going to change in R6, between R6 and R7. Sorry, it's not an interface level command, it's a global command. You need to do it on every router. So I'm going to say this.
On this one, the metric type one that you mentioned, so is that a value that I can specify by my own, or is it the one that you just
when
showed
did I
right
give?
now?
I didn't give.
No, the metric type space 1, this value.
That we have a
value
type.
1.
It is not value, it is a type. Means 1 means
It's a type.
add
Okay.
the pathcast. See, 1 means add the pathcast. If you don't mention this, it is 2. E2, E1. You saw, no? E2, E1. This is E1.
Okay. So I thought 1 was a variable value.
No. So
Got it.
this is the command to change the numerator reference bandwidth value. Autocast reference bandwidth and I'm going to say 1000. See, reference bandwidth is changed. Please ensure that the reference bandwidth is consistent across all router. Yes, we need to put it on all router. So R5.
These all are kind of architecture level inputs. So like within an enterprise,
you have to
multiple devices will be interconnected. So you have to make sure that this goes from the day one itself.
Yeah. Okay, now we have changed. So now we have changed the numerator as 1000. The bandwidth is also 1000, so the cost is 1. But if I will have one fast Ethernet, it will be like 1000 divided by 100, because fast Ethernet is 100 meg. Then the cost is going to be 10. We don't have in our environment, I'm just telling you. If you have, that is how it is. Now, I don't think there will be a change because it is gig Ethernet everywhere. Now, what is next?
Just a question related to this. Like, got OSPF V3. So does V3 have?
V3 is different. Don't worry about the topic. It is IPv6. We'll do it later.
Okay.
Now we have learned 3 things. One is O, another one is OIA, another one is E. In E2 flavors, default is E2, which means for type 5, don't add the pathcast. Do not, which is default. But as you said, if you have multi-exit to ISPs, to find the shortest low-cost path exit, you may need to calculate the pathcast. So you just go to the redistribution point and say, I want type 2 metric type, sorry, type 1, metric type 1, as I said in R6, metric type 1. Now, after some time, we are going to learn N1. Instead of E, it is going to be N, because we are going to make the area as a not so stub area. So instead of type 5, it is going to be type 7. That is why N. For N, add the pathcast. For N, don't add the pathcast. N2 is default. If you say metric type 1, then it's going to be N1. Same story what you learn here. Only the difference is this is type 7, this is type 5. We will see this only when we go to not so stub area. Now, we have not configured any stub, and we check the size of the routing table. Show IP route summary. We got 8,524. All right. Now, what are you doing? What are you going to do to reduce the size? I'm planning to do stub instead of summarization. How can I reduce? Show IP route OSPF. I see that this I can ignore. Instead of learning these many external routes, I just want to have a simple default route. See, we don't have this link. We have shut down this link. There is only one exit for this area, which is R3. Even if you have this link, it is going to be R3 only. So why unnecessarily, we keep the external routes, the routing table, these routes very rarely we use. So it's unnecessary to have it. Instead, we want a default route. We just simply want a default route. So I want to make this area 1 as a stub area. First type of stub we are learning. We are going to go to every router and say area 1 is a stub router. Every router. You need to say that. After you say that, you come to R1 and check this database. Show IP OSPF database. You should not see type 5. You should not see type 5. And you will be seeing an additional default route as type 3. You will have a default route to reach all this external. So when I make that area as a stub area, I will not see this. It's type 4 and 5. So advantage is my database is becoming smaller in size, and the routing table also, you will not have this E external networks, any E network you won't need to, but you will be still able to ping this. It is because you will get a default route which you don't see now. Right now you don't see any OSPF default route. Do you see any default route on the routing table?
No.
Let me show you once again. See, there is no default route. No default route. But after you configure that area as a stub area, you will get a dynamically injected default route. Who will inject it? Your ABR will inject it. To whom? To every internal area 1 member. Okay, please carry on now. Go to R1, R2, R3 and configure area 1 stub command under OSPF. As soon as you configure on R1, you will lose neighborship with R2. Why? Why? Because hello packets will carry the stub information. That should match. That's all. See, you will lose the neighbor now. Gone. Now what I'll do is I'll sniff a packet. Oh, hold on, please. I'll sniff a packet between R1 and R2. I'll show you those stub information. The bit will be on. The stub bit will be on. Okay, here is a hello coming from R1. It's a hello packet, OSPF hello packet. It clearly shows. And I'm going under OSPF. I'm going under OSPF header. No, not header. Yeah, optional. Yeah, you see. For not so, this is for not so stub area. This is hello from R2. Okay. Stub is marked where it is. This is for not so stub area.
Holding the header.
Yeah, here. See this one. This is saying external routing capability, where it is coming from, you see, R2. What is external routing capability? Which means it is not stub. You understood this one?
Okay.
What is external routing? Not stub. It is capable of external routing. It is not stub. Whereas coming from R1, if you see, it is 0. It is not capable. It is not on. Not capable. Alright, that is what stub. Because you configured stub on R1, it says not capable. Whereas coming from R2, it is capable. Now let us go to R2, configure stub. What happened? R2, please. So neighbor will come up now. See, neighbor has come up. Sorry, it's going to come up. R3 has gone down. R2 neighbor, R1 neighborship has come. Now, hold on, please. You see, packet coming from R2 is also not capable. You see, both R1 and R2, it says not capable. This is R1. This is R2, not capable because you configured stub. Alright, fine. Finish on R3, please.
So now R3. Okay. I say
area 1 only. You are not saying area 0.
Area 0 or any other area, correct.
Area 0 should not be made a stub.
Should not be stub, correct. Because that's a transit area.
That's
It can't be.
You see, the size has reduced. Now go and check the database. Show IP OSPF database. OSPF database. Show IP OSPF database. OSPF. Maximize the screen. You will not see type 4 and 5.
Okay, yes.
And you got an additional. You got an additional default route in the database. You see, this was not there before. Now if you check the routing table, show IP route OSPF, you have a default route and there is no E2.
Okay.
There is no E, but ping and see 777, ping 7.7.7.7, which is external. The ping still happens.
So R7 will, R7, R6, all those routers will still get the precise routes.
Yeah. Only this area routers.
Okay.
Only R1, R2 in our example topology, they won't be seeing external routes. R3 will see it because R3 is also a member of what? Yeah, it's a member of area 0. So if you go to R3 now, there will be two databases. In one database you will have type 5 and another one you will not have type 5. Show IP OSPF database. Maximize. See, this is area 0 database. You see, can you highlight area 0? Yeah. Type 1 is there. Type 2, type 3 you are seeing. Spacebar. Type 4 you are seeing. Type 5 also you are seeing.
Type 5.
No.
Okay,
where is
now
type
comes
5?
the area 1.
Where is type 5? Okay, this is type 0. This is type, okay, type 1. Go down. Yeah. See, type 5, this is for area 0. It's for area 0. See, in area 0 type 5 is missing. You see type 4 and then area 1 started. It is actually a part of the one which you see here is a part of area 0. If it is not mentioned area 1, it means what? Area 0. You got it?
Yeah. Understood.
Yeah, because area 1 filters out type 5. Alright, what is next? Next is you got some new enlightenment. What is that? Okay, we have a default route to reach the external network. What is the use of me having other area? Even for other area, I am going to use the same ABR.
Correct.
Why can't I filter type 3 also? Yeah, Cisco says, you don't worry, I'll help you to do that. What Cisco says is, you just go only to the ABR router, which is bringing you the type 3. What is type 3? Routes of other area.
Inter area.
So you need not to go to any other router. You see, it's very, very meaningful statement I'm doing. Because R3 only can generate this type 3 LSA, you go only to R3 and add one additional keyword called no summary. What is summary? Summary means type 3. So to the previous stub configuration only you are going to do it. In R1 and R2 you still have that stub already configured. Keep it.
Yeah.
Keep it. Along with that, in R3 you just say no summary. Please do it.
But usually the so APR does the summary, but the way it does it is like it'll be from so it'll be from this area 1 where it is sending outside the area, which is to area 0. That time it does the summarization. But now what we are saying is anything coming inbound
that is also
from
summary
any other
LSA only.
area.
That is also other area only, no? Coming
Yeah, so,
inbound, going out, both are other area. For area 0, area 1 is area 1 is type 3. For area 1, type 0 is area 0 is type 3.
Understood. Yeah. Means I'm just trying to map it. So like means my understanding. I'm just trying to map it out here. So like the summarization that we say, summarization has nothing to do with the type 3 LSA.
No.
It's just that
it's just a name by summary LSA because it is originating from the summarization point.
From the point. Okay, understood.
Okay. Carry on, please.
Okay. So then area 1. No summary.
No, you are doing wrong. Why are you doing this in R1? Is R1 generating summary?
Oh, okay. Sorry. It should
Go
be
cancel R1 first. R1 should have.
Sorry, my bad.
No. R1 should have area 1 stub command.
I'm just checking that.
It is there.
Yeah, it's still there.
Good.
Yeah, that's what I was checking. Okay. Sorry.
remove the old one. Enter this. And remove the old one. No, and then whatever you highlighted, paste it here. Enter. Right, and one more time for assurance, you just hold on, please.
Oh, sorry.
All right, fine. The neighbor will reset. It will come back again. It will come back again. Okay. Now go to.
Sorry. So area 1 stub. So if I type area 1 stub and area 1 stub no summary, it's just gets replaced.
No, for me, I want to make sure that this old one is removed.
No. Oh, okay.
It's for my confirmation.
Okay.
Now, go and check the database in R1. You should not see type 3 also.
Okay.
No. Show IP OSPF database. Maximize.
Correct.
You see only type 1 and type 2. As a type 3, you get only summary LSA. Why it is coming as type 3? Because ABR only gave you this. Sorry, not summary LSA. Default route. Because type 3 is from ABR. Your default route is also from ABR. That's why it shows us type 3 summary. Check the routing table. Your routing table will be very small now. You will have only the local networks. See, O only you have. You don't have IA. For IA and for E, for both IA and E, what you have is a default route. So try to ping 55555, which is an ABR between area 2 and area 0. You will be able to ping 777, which is an external. Still you will be able to ping. And check the size of the routing table. Previously from 8000 it came to 6000. No, show IP route summary. Now it has gone to 4000. So more than summarization, this is more effective than summarization. It's more effective than summarization. Okay. So what we'll do is we'll stop here. Tomorrow we'll continue with the other two with much clarity. Hope these two are clear for you.
Yeah, it's clear. Whenever you have time, please upload this video. So I'll revise this before we get into tomorrow's session.
I'll do it. It will be done in few minutes.
Okay.